Welcome to The Explainer. Today, we're decoding a massive shift happening right under our noses. You know, for the past 20 years, having your own gleaming, humming server room was kind of the ultimate badge of corporate honor. Banks, telecom giants, manufacturers, even your average mid-sized business, they were all super proud to showcase their in-house infrastructure. But today, we're seeing proud enterprises literally dismantle their massive data centers. They're taking thousands of servers and migrating the whole shebang to the public cloud.
So let's dive right into this mystery. Why on earth is a practice that used to be the absolute standard for doing business suddenly being treated like this massive, expensive liability? What's really driving this great industrial migration from the basement server room up to the invisible cloud?
Here is our roadmap for today's explainer. We're going to cover the hidden costs of on-premise IT, the idle resource dilemma, the CapEx to OpEx cloud shift, how AI accelerates migration, product priority, and finally, the hybrid cloud future. Let's get into it.
All right, Section 1, the hidden costs of on-premise IT. If we look back to any time before 2010, building your own data center was just the default. But look at this legacy process. It's wild. Before you could launch a single new app, you essentially had to become a general contractor. You had to physically buy the servers, construct a dedicated room, pull miles, and I mean miles, of networking cable, install heavy-duty cooling, and then hire an army of people just to keep the lights blinking.
This right here gives you a great look at the old way. It was this totally rigid, top-down architecture. Everything from the app layer right down to the literal physical floorboards was in your hands. Sure, the upside was absolute control. Your data never left the building. But man, that control came at a staggeringly high premium.
And this brings us to the classic iceberg illusion. When budgeting, execs naturally assumed the computer processors, the servers themselves, were the main cost. But check this out. A standard server pulls maybe 500 to 1500 watts. The catch? The massive industrial cooling systems needed to keep those servers from literally melting down pull the exact same amount of electricity. So your cooling practically doubled your power bill before you even processed a single byte of customer data. It was this huge, invisible cost that routinely wrecked IT budgets.
And it wasn't just the doubled power bill. Companies were bleeding cash on crazy spatial safety requirements. We're talking commercial fire suppression, waterproofing, heavy access control, massive backup diesel generators. Plus, you couldn't just hire an IT guy. You needed dozens of highly specialized operational staff. Network engineers, storage experts, database admins, the list goes on and on.
Moving right along to Section 2, the idle resource dilemma.
Imagine the sheer waste happening here. Say you're an e-commerce brand getting ready for a massive shopping event, like Singles Day or Black Friday. To handle that insane traffic spike without your site crashing, you have to preemptively buy, say, 100 servers. But on a random Tuesday in March, you only need 20. Since you can't exactly run out and buy servers the second traffic spikes, you're forced into over-provisioning. That means 80% of your incredibly expensive hardware just sits there, utterly idle, burning electricity for most of the year. If you buy too few, your site crashes. Buy enough to survive, and you waste millions. It's a lose-lose.
Which brings us perfectly to Section 3, the CapEx to OpEx cloud shift.
The industry desperately needed a way out of that trap, and the public cloud solved it, not just with better tech, but by completely flipping the financial model on its head. It took IT from a massive capital expenditure where you sink $5 million up front before writing a single line of code to an operational expenditure. Suddenly, compute power became instantly rentable. Need 10 virtual machines right this second? Click a button. Traffic spikes 10 minutes later and you need 100? The platform automatically scales. It's like turning a faucet on and off, and you only pay for exactly what you use.
Okay, Section 4, AI accelerates cloud migration.
Now, the modern AI boom has basically taken this migration trend and poured rocket fuel on it. If an enterprise wants to train sophisticated AI models today, the required tech stack is overwhelmingly complex. We are way past standard web servers here. You need clusters of high-end GPUs that cost tens or even hundreds of millions of dollars. Plus, specialized NVLink interconnections, highly advanced networking, and storage so fast it'll make your head spin just to keep those GPUs fed with data.
Because of this insane tech requirement, enterprises are staring down a brutal catch-22. GPU tech is moving so incredibly fast. Every year or two, there's a massive leap in performance. So if a company drops $50 million on an AI cluster today, it depreciates incredibly fast. It could be functionally obsolete in months. But if they wait, they completely lose their competitive edge. So what do? Almost everyone just rents their AI infrastructure now. They let the cloud providers deal with the massive headache of hardware depreciation while they focus purely on actually utilizing the AI.
This leads us right into Section 5. Your product is the priority.
This overwhelmingly complex tech stack forces a massive realization about human capital. I absolutely love this quote. Don't waste engineers on swapping hard drives. It hits the nail on the head. Managing infrastructure today isn't just knowing a bit of Linux anymore. It's Kubernetes, infrastructure as code, CI/CD pipelines. It's dense. Companies have finally realized that a bank's true competitive edge is, being a great bank, providing exceptional financial services, not managing server racks. An e-commerce brand's edge is the shopping experience, not configuring network switches. The cloud lets companies redirect their most brilliant minds back to building their actual product.
And finally, Section 6, the hybrid cloud future.
So looking at all this overwhelming evidence, is every single company going to completely abandon their physical servers? Well, no. The reality here is the hybrid cloud model. While the public cloud is definitely the default now, data centers aren't totally dead. They're just getting highly specialized. If you're a massive telecom dealing with ultra-low latency, or a bank bound by strict compliance laws, you absolutely still need some private infrastructure. And obviously, megacorporations like Google or Meta operate at such a crazy scale that building their own stuff is actually cheaper. But for almost everyone else, a hybrid approach, keeping core, ultra-sensitive systems private while running general operations in the cloud, is the dominant strategy.
As we wrap up this explainer, I want you to consider this. There are startups right now that will go from their founding day all the way to a massive IPO without ever owning a single physical server. The invisible infrastructure of our digital lives has permanently shifted to mega centers distributed around the world. So you have to ask yourself regarding your own business. Are you wasting precious time and human capital managing depreciating hardware, or are you fully focused on innovating and creating actual value for your customers? The future definitely belongs to those who choose the latter. Thanks so much for joining me on this explainer, and I'll catch you on the next one.